This is SpaceTime, Series 27, Episode 120, for broadcast on the 4th of October 2024. Coming up on SpaceTime, planet Earth just got a second moon. A new study claims the red planet Mars could be hiding its missing atmosphere in plain sight. And Russian cosmonauts return to Earth after a record stay aboard the International Space Station. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Planet Earth just got another second moon, a tiny near-Earth asteroid that's been temporarily caught up in our planet's gravitational field. The asteroid 2024 PTS was captured on September the 29th, and after swinging around the planet will be flung off on November the 25th after a stay of just 57 Earth days. The 10-metre wide space rock, which is from the Arjuna asteroid group's too small to be seen with the unaided eye, but it can be spotted by telescope. 2024 PTS is only the fifth ever detected moon captured by Earth. It was discovered using the Atlas Asteroid Terrestrial Impact Last Alert System, which is designed to search for asteroids and other near-Earth objects. A mini-moon, as they're called, is a temporarily captured asteroid that completes at least one full orbit of the Earth before returning to its usual orbit around the Sun. If a mini-moon's captured by Earth's gravity but doesn't make it all the way around in a full orbit, it's called a temporary captured flyby. 2 of the 5 mini-moons detected orbiting the Earth so far have been temporarily captured orbiters, while the other 3, including 2024 PTS, are temporarily captured flybys. The first known mini-moon spotted orbiting the Earth was 1991 VG. Now, as the name suggests, it arrived in late 1991 and it finally left Earth orbit in 1992, and like 2024 PTS, it was around 10 metres in diameter. It was discovered by the Spacewatch telescope. In 2002, citizen scientists spotted what at the time was thought to be a second mini-moon, catalogued as J002E3. However, on closer examination, spectroscopic readings showed that it was coated with white paint containing titanium oxide. Further analysis showed the object's brightness changed over time, and its shape was more like a giant cylinder. It turned out this was actually the upper stage of a Saturn V Apollo moon rocket. Another mini-moon, catalogued as 2006 RH120, was discovered on September 14, 2006, this time by the Catalina Sky Survey Spacewatch program in Arizona, which scans the skies looking for near-Earth objects. It was between 2 and 7 metres across and remained in orbit around the Earth for a full Earth year, from July 2006 until July 2007. The next mini-moon discovery was 2020 CD3. It was gravitationally captured by the Earth for more than 2 years, making it the longest known captured mini-moon observed to date. It was between 1 metre and 2 metres in diameter and finally escaped Earth's orbit in May of 2020. Then came 2022 NX, a 5 to 15 metre wide space rock, which, just like 2024 PTS, originated from the Arjuna's asteroid group. And there was a bit of a surprise associated with the space rock. It turns out to have been orbiting the Earth for quite a while, between January 1981 and June 2022. And 2022 NX isn't done with the Earth just yet. It's coming back for another spin, although that won't be until December 2051. The latest computer modelling suggests that planet Earth has at least one captured mini-moon, less than 1 metre in diameter, orbiting it at any given time. This is SpaceTime. Still to come. A new study claims the missing Martian atmosphere could be hiding in plain sight in the red planet's crust. And a pair of Russian astronauts have returned to Earth following a record stay aboard the International Space Station. All that and more still to come on SpaceTime. A new study claims the missing Martian atmosphere could be hiding in plain sight in the red planet's crust. Mars has only 1% of the atmospheric pressure of Earth at sea level. But at some point in its distant past, it must have had a much thicker atmosphere in order to be able to allow water to exist in a liquid state. One of the currently accepted hypotheses suggests that Mars, being a lot smaller than the Earth, cooled down a lot quicker, eventually resulting in its liquid iron core solidifying. As the core solidified, the Martian geodynamo stopped working, and that caused the planet's magnetic field to break down. Now, a planet's magnetic field is really important because it helps shield the planet from radiation in the solar wind, which is constantly streaming out from the sun. The radiation can break apart heavy molecules, allowing them to degas into space. And the solar wind can quite literally erode the planet's atmosphere into space. This process over billions of years is thought to have turned Mars from a warm, wet world, one capable of hosting life if it ever existed there, into the freeze-dried desert it is today. Scientists speculate the red planet's water dried up about 3.5 billion years ago as the air, once heavy with carbon dioxide, dramatically thinned, leaving only the wisp of an atmosphere that clings to the planet today. Now, a new study, reported in the journal Science Advances, suggests that instead of disappearing into space, the missing Martian atmosphere could have been locked up in the planet's clay-covered surface. The authors claim that while water is present on Mars, the liquid could have trickled through certain rock types and set off a slow chain reaction, which progressively drew carbon dioxide out of the atmosphere and converted it into methane, a form of carbon that can be stored for eons in the planet's clay surface. And we know that's possible on Mars because a similar process occurs in some regions on Earth. The authors used their knowledge of interactions between rocks and gases on Earth and applied that to how similar processes could play out on Mars. They found that given how much clay is estimated to cover the Martian surface, the planet's clay could hold up to 1.7 bar of carbon dioxide, which would be the equivalent of around 80% of the planet's initial early atmosphere. Now, based on these findings on Earth, similar processes likely operated on Mars, and that copious amounts of the atmospheric carbon dioxide could have transformed into methane and be sequestered in the clays. The authors say this methane could still be present and may be used in future as an energy source for humans when they finally get to Mars. Now, when this story first began, the authors weren't even looking at Mars. They were looking to identify the geological processes and interactions that drive the evolution of Earth's lithosphere. That's the hard and brittle outer layer which includes the crust and the upper mantle, where the tectonic plates lie. They focused on a type of surface clay mineral called smectite, which is known to be a highly effective trap for carbon. Within a single grain of smectite are a multitude of folds within which carbon can sit undisturbed for billions of years. They showed that smectite on Earth was a likely product of tectonic activity, and that once exposed at the surface, the clay minerals acted to draw down and store enough carbon dioxide from the atmosphere to cool the planet over millions of years. Soon after the team reported their results, one of the study's authors happened to be looking at a map of the surface of Mars, and realised that much of that planet's surface was also covered in the same smectite clays. And that raises the question, could clays have a similar carbon-trapping effect on Mars? And if so, how much carbon could be stored there? But there's one problem. Unlike the Earth, where smectite's a consequence of continental plates shifting and uplifting to bring rocks from the mantle to the surface, there's no such tectonic activity on Mars. So, the team looked for ways in which these clays could have formed on Mars based on what scientists knew about the planet's history and composition. For instance, some of the remote measurements of Mars' surface suggest that at least part of that planet's crust contains ultramafic igneous rocks, similar to those that produce smectites through weathering here on Earth. Other observations reveal geologic patterns similar to terrestrial rivers and tributaries where water could have flowed and reacted with the underlying rock. The authors wondered whether water could have reacted with Mars' deep ultramafic rocks in a way which would have produced the clays that cover the surface today. So they developed a simple model of rock chemistry based on what's known about how igneous rocks interact with their environment on Earth. They applied this model to Mars, where scientists believe the crust's mostly made up of igneous rock which is rich in the mineral olivine. The authors used the model to estimate the changes that olivine-rich rocks might undergo, assuming that water existed on the surface of the red planet for at least 1 billion years, and that the atmosphere at the time was already thick with carbon dioxide. Over about 1 billion years, they found water trickling through the crust would have slowly reacted with the olivine. That's a mineral which is already rich in a reduced form of iron. And oxygen molecules in the water would have bound to the iron, releasing hydrogen as a result and forming the red oxidized iron which gives the red planet its iconic colour. This free hydrogen would then have combined with the carbon dioxide in the water to form methane. As this reaction progressed over time, the olivine would have slowly transformed into another type of iron-rich rock known as serpentine, which then would have continued to react with water to form smectite. The authors found that if Mars is covered in a layer of smectite that's at least 1,100 metres deep, the amount of clay there could store a huge amount of methane, the equivalent to most of the carbon dioxide in the atmosphere that's thought to have dispersed since the planet dried up. This is space-time. Still to come, Russian cosmonauts return to Earth after a record stay on the International Space Station. And the nearest star system to the Sun, the Large and Small Magellanic Clouds, and 3 meteor showers in the space of just 1 month are among the highlights of the October night skies on Skywatch. Two Russian cosmonauts have landed safely on the vast windswept Kazakhstan steppe following a record-breaking 374-day stay aboard the International Space Station. It's the longest amount of time any humans have stayed aboard the station in one continuous stint. The pair, together with an American astronaut who lived on the station for the past 6 months, returned to Earth aboard the Soyuz MS-25 capsule, which had undocked from the orbiting outpost 3.5 hours earlier. By the way, the absolute record for the longest unbroken time any human has spent in space belongs to Russia's Valery Polyakov. He spent 438 days aboard the Mir space station in 1994-95. Right now, 8 crew members remain aboard the International Space Station, including Americans Butch Wiltmore and Sonny Williams, who have remained long past their scheduled return to Earth after NASA decided to send them home aboard a SpaceX Dragon capsule in February next year, rather than aboard the trouble-plagued Boeing Starliner spacecraft which they flew up on, turning their 8-day test flight into an 8-month mission. The Starliner, by the way, eventually returned to Earth safely but unmanned. This is space-time. And time now to turn our eyes to the skies and check out the celestial sphere for October on Skywatch. October is the 10th month of the year, and that may seem confusing since octo in Latin means 8 rather than 10. The answer lies in the old Roman calendar, which had just 10 months before the addition of January and February. And that 10-month year is still reflected today, with the name September or Septem being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. Of course, the highlight of October for kids and those who are young at heart has to be the last day of the month, celebrated as All Hallows Evening or Halloween. Halloween is based on ancient Celtic pagan festivals such as Samhain, the Gaelic festival of the dead. Samhain was eventually Christianized by the early church to become All Saints or All Hallows Eve, or simply Halloween. It's a time when darkness overtakes the light of day, a reference to the increasing hours of darkness as the planet's northern hemisphere moves towards longer winter nights. And so it's a time when the harvest comes to an end. The increased hours of darkness mean the boundary between the world of the living and the world of the dead becomes especially thin, allowing the dead and supernatural to rise in search of the living. And so the living wear disguises so as not to be recognized by the dead, and it's this which has led to today's tradition of the Halloween fancy dress party. In some parts of the world, cross-dressing is popular on Halloween, a reflection of the secret desires and fantasies of their pagan ancestors, sometimes not so many generations removed. To ensure that crops and livestock survive the cold winter months ahead, offerings of food and drink would be left outside for the spirits and fairies of the other side. And it was this which ultimately led to today's practice of trick-or-treat. Also, candles would be lit and prayers offered to the souls of the dead, as Halloween was a time when the spirits of the dead would return to their former homes. Special bonfires were also lit on Halloween to light the darkness, thereby preventing souls of the dead from returning and keeping the evil away. The flames, smoke and ashes were deemed to have protective and cleansing powers and were used for divination. As for the tradition of carving pumpkins into jack-o'-lanterns, Well, that was originally meant either to represent spirits or supernatural beings, or alternatively to ward off evil spirits. In many parts of the world, the Christian religious observances of All Hallows Eve include attending church services and lighting candles on the graves of the dead. And Christians historically abstained from eating meat on All Hallows Eve, a tradition reflected in the eating of certain vegetable foods on the day, including apples, potato pancakes, and soul cakes. Apple bobbing originated because the apple was a Celtic symbol of love, and so grabbing the apple with your teeth had certain erotic overtones. Halloween is a time of fortune-telling and divination games, playing pranks to scare people, visiting haunted attractions, telling scary stories, and of course watching horror movies. Looking to the southwest, you'll see the two bright pointer stars, which show the way to the Southern Cross. The brightest, and what also looks like the more distant of the two stars from the Southern Cross, is Alpha Centauri, which is actually the nearest star system to our own solar system. Alpha Centauri is a triple star system comprising two stars, Alpha Centauri A and B, which orbit each other in a binary, and a third star, Proxima Centauri, which orbit the pair. Like the Sun, Alpha Centauri A is a spectral type G yellow dwarf star. It's about 10% more massive than our Sun and about 1.5 times as luminous. Astronomers describe stars in terms of spectral types. It's a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our Sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are the spectral type M red stars. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now you put all that together and our Sun becomes a G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a unique category between the largest planets, which can be up to 13 times the mass of Jupiter, and the smallest stars, those spectral type M red dwarf stars we mentioned earlier. These can be 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. Alpha Centauri A's binary partner, Alpha Centauri B, is a spectral type K orange dwarf star, a little smaller and cooler than its companion, with about 90% of the Sun's mass and about half its luminosity. This binary pair, Alpha Centauri A and B, orbit each other at between 11.2 and 35.6 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, which equates to about 150 million kilometres, or around 8.3 light minutes. So the pairs' orbit around each other varies by between the average distance between the Sun and Saturn and between the Sun and Pluto. It takes the two stars 79.91 Earth years to complete each orbit. On average, Alpha Centauri A and B are located 4.37 light years from the Sun. Now, although a light year sounds like a measure of time, it's actually a measure of distance. A light year is a distance of about 10 trillion kilometres. That's the distance a photon can travel in a year at the speed of light, which is around 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. The third star in the Alpha Centauri system is a spectral type M red dwarf star named Proxima Centauri. Right now, Proxima Centauri is just 4.25 light years away, making it the nearest star to the Earth other than the Sun. It is only loosely gravitationally bound to Alpha Centauri A and B, orbiting the pair at an average distance of 13,000 astronomical units, or around 0.21 light years. That's about 430 times the size of Neptune's 30 astronomical unit orbit around the Sun. In 2016, astronomers confirmed the existence of an Earth-sized terrestrial planet orbiting within the habitable zone of Proxima Centauri, making it the nearest known extrasolar or exoplanet to Earth. The habitable zone, which is sometimes also referred to as the Goldilocks zone, is that area out from a star where it's not too hot, not too cold, but just right for liquid water, essential for life as we know it, to exist on a planet's surface. The planet, known as Proxima b, takes just 11 Earth days to complete one orbit around its host star. That's far closer than Mercury's 88 Earth day orbit around the Sun. A few years ago, a second, more distant planet, Proxima c, was also discovered orbiting around the star, but well outside its habitable zone. The second and slightly fainter of the two pointer stars is Beta Centauri, and while Alpha Centauri is the third brightest star in the night sky, outshone only by Sirius and Canopus, Beta Centauri is only about the 10th brightest. Looking to the southeast, and you'll see the bright blue-white star Alpha Eridani or Achernar, which represents the southern tip of Eridanus, one of the largest and longest constellations in the sky. Achernar is located about 139 light-years away. It's actually a binary star system comprising two stars, Alpha Eridani A and Alpha Eridani B. Alpha Eridani A is a hot young spectral type B blue star. It has about 6.7 times the mass of the Sun, and a stunning 3,150 times the Sun's luminosity. By comparison, the companion star Alpha Eridani b appears to be a spectral type A white star with about twice the Sun's mass. The two stars orbit each other every 14 to 15 Earth years at an average distance of about 12.3 astronomical units. Because of its high rotation rate of over 16 km per second, Alpha Eridani A is actually one of the least spherical stars in the Milky Way, spinning so rapidly it's assumed the shape of an oblate spheroid, with an equatorial diameter 56% greater than its polar diameter. This distorted shape means the star displays a significant latitudinal temperature, with its polar temperature being about 20,000 Kelvin, while its equatorial temperature is only around 10,000 Kelvin. That's because it's much further away from its stellar core. The high polar temperatures are generating a fast polar wind. That's ejecting matter from the star and creating a spectacular polar envelope of hot gas and plasma. Now, if you look up between the South Celestial Pole and Achernar from a really dark place, you'll see two faint fuzzy-looking clouds. Now, these aren't actually clouds. They're two satellite dwarf galaxies which orbit the Milky Way, known as the Large and Small Magellanic Clouds. They're named after Ferdinand Magellan, who became the first European to officially record them during his expedition to circumnavigate the Earth between 1519 and 1522. The bigger and nearer of the pair is the Large Magellanic Cloud, which is located around 160 light-years away. It's easier to spot about halfway between Achernar and the horizon. It's about 14 million light-years across, twice that of the Small Magellanic Cloud, which is located a more distant 200,000 light-years from the Milky Way. Now, by comparison to these two satellite galaxies, the Milky Way is huge, 100,000 light-years across. These two dwarf galaxies are separated from each other by roughly 75,000 light-years. The Magellanic Clouds were considered the closest galaxies to the Milky Way until the 1994 discovery of the Sagittarius Dwarf Elliptical Galaxy and the 2003 confirmation that the Canis Major Dwarf Galaxy is actually our nearest galactic neighbour. The total mass of the Magellanic Clouds is uncertain. Only a fraction of their gas seems to have coalesced into stars. They also probably both have very large dark matter halos. Still, one recent estimate places the total mass of the Large Magellanic Cloud at about 1/10 that of the Milky Way. The Magellanic Clouds have both been greatly distorted by gravitational tidal interactions as they're gradually torn apart and absorbed by the Milky Way. These huge tidal forces have turned both Magellanic Clouds into irregular disrupted barred spiral galaxies. The Large Magellanic Cloud still retains a very clear spiral structure, at least in radio telescope images of neutral hydrogen. But gravity isn't a one-way street, and the combined gravitational force of both Magellanic Clouds is also affecting the Milky Way, distorting the outer parts of our galactic disk. And there are streams of neutral hydrogen gas clouds and isolated stars, connecting both dwarf galaxies to each other and to the Milky Way. A brilliant example of galactic cannibalism at work. Now, if you look just above the Small Magellanic Cloud using a backyard telescope or a good pair of binoculars, you'll see a small blurry dot. That is the 47 Tucanae globular cluster. A tightly packed ball of stars some 16,000 light-years away, they were all originally formed at the same time through the gravitational collapse of the same molecular gas and dust cloud. If you look to the west, you'll see the bright reddish-orange supergiant star Antares, the heart of the constellation Scorpius the Scorpion. And above it you'll see a bunch of stars stretching out shaped like a reverse question mark. That's the tail of the Scorpion. Now, just above and to the north is the constellation Sagittarius the Archer. Sagittarius shows the way to the supermassive black hole at the centre of the Milky Way galaxy, some 27,000 light-years away. This monster black hole, known as Sagittarius A star, has about 4.3 million times the mass of our Sun. Now, looking to the north-northwest this time of the year, you'll see the constellation Lyra the Harp, and its brightest star Vega, the fifth brightest star in the night sky, and one of the closest at just 25 light-years away. Vega is a spectral type A white star, more than twice the size and some 40 times the mass of our Sun. Now, just to the right of Lyra, and almost directly north just above the horizon, is the constellation of Cygnus the Swan, and its brightest star Deneb, one of the most luminous stars in the sky. Deneb is a massive spectral type A white supergiant, some 19 times the mass and over 100 times the diameter of the Sun. The star is somewhere between 55,000 and 196,000 times as luminous as the Sun. The huge range in luminosity estimate is caused by the difficulty in determining Deneb's exact distance from us. Science's best estimates place it somewhere around 2,600 light-years away, give or take 212 light-years. High in the northern sky right now is the constellation Aquila the Eagle, and its brightest star Altair. Altair is another spectral type A white star, but located a lot closer, just 17 light-years away. It's about 10 times brighter than the Sun, with about 1.89 times the Sun's mass. Despite its size, Altair spins on its axis in just 10 hours, compared to our Sun's 28 Earth day rotation. Now, these three stars, Altair, Deneb and Vega, form a stellar grouping known as the Summer Triangle. Now, also in October, there are three meteor showers: the Draconids, the Taurids and the Orionids. The Draconids take place on October the 8th. They're so named because their meteors appear to radiate out from the constellation Draco the Dragon, and so are best viewed from the northern hemisphere. They're actually produced as the Earth's orbit takes it through the debris trail left behind by the comet 21P Shihokubini-Zinna, which takes about 6.6 Earth years to make a single revolution of the Sun. The Taurids meteor shower takes place on October 10th, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Their meteors are composed of larger than average pebbles and dust grains, and are thought to be generated by debris left behind by the comet 2P Encke. Although it's thought that both the Taurids and Encke could be the remains of an earlier comet which disintegrated over the past 20,000 to 30,000 years, breaking into several pieces and releasing material both by normal cometary activity and possibly also by gravitational tidal interactions with the Earth and other planets. The Taurids debris stream is the largest in the inner solar system, taking the Earth several weeks to pass through and resulting in an extended period of meteor activity compared to other meteor showers, which are usually over in just a matter of days. Now, due to the gravitational perturbations of the planets, especially Jupiter, the Taurids have been spread out over time, allowing separate segments, labelled the northern Taurids and southern Taurids, to be observable at different times in different hemispheres. The southern Taurids are active from around September the 10th to November 20th, while the northern Taurids are active from October the 20th to December the 10th. The third meteor shower this month is the Orionids, which peak on October the 20th. They're caused by debris from the comet Halley, which also causes the Eta Aquarids meteor shower in May. Comet Halley takes 76 years to complete each orbit around the Sun. It'll next become visible near Earth in 2061. The Orionids are equally spectacular in both northern and southern hemisphere skies, with up to 20 meteors an hour radiating out from the constellation Orion. The best time to see the Orionids is just after midnight and right before dusk. And joining us now for the rest of our tour of the October night skies is science writer Jonathan Alley from Sky and Telescope magazine.
G'day, Stuart. Yeah, October. It's a good time for stargazing, actually. Where I live, the evenings are really nice. They're not too cold, not too hot, sort of Goldilocks evenings. The nights are still long because I live in the southern hemisphere, so we're heading towards summer, of course. And when we get to summer, beautiful weather, but the hours of darkness are less than they are at other times of the year, which means less time for viewing. But at the moment, everything's really nice. Weather's good, nights are still long. So if you go outside and look up this time of the year, you'll see the Milky Way, the band of stars that's our galaxy's infinite inside. You'll see it stretching from north to the south, just a little bit to the west of directly overhead. So if you're looking from where I am, it's directly overhead. But if you're looking to say from the north, the west is to your right. And if you're looking from the south, the west is to your left. Anyway, go outside and have a look and you see the Milky Way north to south. Looks really magnificent. Where I am, we've got the constellations of Sagittarius and Scorpius, which really does look like a scorpion, by the way. They're almost overhead and they're easily visible and really, really beautiful. If you can get out to some dark skies, get away from all the light pollution in the city and just see the Milky Way up there, it's really amazing. It's something you really miss living in the city. You know, do you remember that famous TV series Cosmos, Carl Sagan?
Yeah, of course.
All those years ago. They did a remake, didn't they? But
yes.
the one from back in about 1980 or 81 or something.
Yeah, I remember. I watched both of them. Yeah.
Well, I remember seeing an interview with one of the people on the production team back then, and because that was the first big astronomy TV series, science series. There have been lots of other nature ones, but that was the first big space one. And they got flooded with letters from people all around the world, kids and things. And they said that they would get letters from people in, say, Tokyo and places like that, which are millions of people and a lot of light pollution. And some of these letters said, these were kids. They said, I didn't realise that stars are real. I thought they just made them up for science fiction because I've never seen stars. Never seen stars. Isn't that amazing?
Isn't that sad?
Yeah, exactly. And that's 40 years ago, so it won't have improved any.
No, it'll have gotten a lot worse.
Gotten a lot worse for a lot more people. So, yeah, if you can get out to some dark skies or even just find a park or a sports field or something where you feel safe and just get away from as much light as you can, let your eyes dark adapt and look up and see if you can see the Milky Way.
When I worked at a radio station up in Darwin in the Northern Territory, I used to regularly drive from Darwin to Sydney and back again, and just parking in the middle of the outback, crashing there for the night, just looking up at the sky and having that entire curtain of light just shining down on you. It's the most amazing thing.
Yeah. Can you imagine living your entire life being able to see that? You know, as people would have been before industrialization and electric lights and things and pollution and traditional societies, of course. So for almost all of our history, essentially all of our history, we've been able to see that magnificent part of nature. But now for so many of us, maybe the majority of us, it's totally separated from us. You know, we just don't see it and don't think of it, and it's really, really sad. So we all need to spend more time somewhere away from cities where you get not only the rest of nature down on the ground, but you see the nature up above as well.
Indeed.
Anyhow, so that's the Milky Way. So
because when you look up at Sagittarius, which you mentioned a moment ago, you're actually looking at the dead centre of the Milky Way galaxy. You're looking towards Sagittarius,
looking towards the middle,
our central black hole.
Yeah, looking right in towards the middle, what they call the central bulge of the galaxy. And that's a good point, actually, because the middle of the evening at this time of year, we see the Milky Way north to south. But as the Earth is turning, the Milky Way will go more towards the west, and eventually it'll set in the west. So later in the evening, around midnight or a little bit after midnight or so, when you go out and have a look, you won't see the Milky Way at all. You just see just a big dark expanse of sky with stars and things in it. And that's because we're now no longer looking in towards the middle of the Milky Way. We're looking at right angles of that out of the Milky Way. The Milky Way is sort of a discus-shaped thing, and we're about 2/3 of the way out from the middle. So if you imagine the sun in 2/3 of the way out from the middle in this discus, if you look at right angles up or down, you're looking through a very thin part of the Milky Way, very thin slice, and that's what we're going to get later in the evening in October. You go out, the Milky Way seems to have disappeared, looking out of the galaxy now. So there doesn't seem to be perhaps as many bright stars as at other times, but there's still plenty to see, so don't worry about that. One thing we can see, if you're down in the south at this time of year, is the Magellanic Cloud galaxies. Our galaxy might be out of view, but the two Magellanic Cloud galaxies, which are fairly sizable galaxies very near to our Milky Way, named after the explorer Magellan, although there's moves afoot to rename them because Magellan's a bit on the nose of some people at the moment, because of the voyage he did and his behaviour of people on board that voyage when they called falls in at various places around the world. Anyway, that's another story. Yes, the magellanic clouds, again, you need dark skies, though, to see them. You really do. I can't see them, really, from where I live in a big city, unfortunately, so you do need some dark skies. But anyway, they're down there, and down south about halfway up from the horizon, the small and large clouds. They're really impressive if you can get a good view of them. Now, a lot of people, of course, want to find the Southern Cross. If you haven't yet identified the Southern Cross up in the night sky, well, it's there, but at this time of year, it's right down low. It's down towards the horizon. From where I live, it's behind houses and trees and things in the evening during October. And for people who live further north, well, it's going to be below the horizon. If you're down in Melbourne or Tasmania, you should still be able to see it, but this is not the best time of year to see the Southern Cross. Now, if you like staying up late or getting up really early for dawn, the post-midnight skies in October are really good because we've got the southern summer or northern winter constellation starting to poke their head above the horizon in the east after midnight. So we get Orion, Taurus, Gemini, Canis Major, and Puppis, all these amazing constellations full of fantastic stuff to see. I really love Taurus and Gemini because they were one of the first couple of constellations I identified when I was a teenager, and just sweeping through them with a pair of binoculars. There's so many star clusters and nebulae and things to see. It's just marvellous. I mentioned Canis Major. That's a constellation of the Greater Dog. It has the brightest star in the sky called Sirius. Orion has got the two bright stars, Rigel and Betelgeuse, and its famous nebula, the Orion Nebula, which you can see as a smudge of light with the naked eye. Again, you need dark skies, and you get an even better view with even just a pair of binoculars or a small telescope. The other constellation I mentioned, Puppis, it's really well known to astronomers but unheard of by members of the public. But it is a real treasure trove of great things to see with binoculars or a telescope. There are some tremendous star clusters and nebulae in it. You can just spend hours just sweeping around there with a telescope with a wide field of view, or just the wide field that binoculars give you. So, that's a southern constellation. Really, really beautiful. It's in the Milky Way, so that's why there's lots of stuff in there, because we're looking through the dense part of the galaxy again to see Puppis. Now, looking at the planets, what have we got in October, this October? In the evening, we've got Venus and Saturn. Venus can be found fairly high above the western horizon after sunset. You can't miss it. It's big and bright, and it's going to stay nice and high and bright all month long out there to the west. Mercury, you can't see for about the first 3 weeks of October, but in the last week of October you should be able to just make it out above the western horizon after the sun has definitely gone below the horizon and it's getting a bit dark. You'll see a small, fairly bright pinprick of that looks like a star, but it is actually Mercury, and Venus is up much higher than it. The other direction, after sunset, out in the east, you can see Saturn, which is about halfway up from the horizon. It looks like a fairly big, bright, yellowish star, but of course it is a planet. And if you're having trouble trying to work out which one of those lights up there is Saturn, wait until the 14th of the month. Go outside that night and find the moon, which of course is easy to spot, and you'll see near it a bright star-looking thing that's slightly yellowish. Well, that bright star that's slightly yellow is Saturn. So that's an easy way to find it. Now, if you continue to stay up late past midnight, or you're out discoing or something like you do a lot, Stuart, or if you're getting up early or you've got to go to work or something, you'll see Jupiter rising in the northeast just after midnight. It's big and bright like Venus, but it has a sort of an orangey sort of tinge to it.
The worst part about what you just said is that it's so true. There was a time when I used to party all night, and then my shift changed at the ABC. I had to do breakfast, and so I would actually be in the cab on the way to work looking at the night rider bus that I would normally take home passing me going the other way. It's so sad.
Oh, so you've gone from doing that to being a fan of the band Kiss, so now you're doing your rock and roll all night and partying all day, is that right? Anyway, where were we? So an orangey Jupiter out there in the northeast. Well, about 2 hours later, 2 a.m., if you're out discoing or partying all night long, you'll see Mars also rising above the northeastern horizon. It's smaller and dimmer than Jupiter, but it's quite easy to spot because it has a really quite definite ruddy reddish colour to it. And that, Stuart, is the night sky for October.
That's science writer Jonathan Alley from Sky and Telescope magazine. This is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.